Okay, so I cannot get KiCad to open up. That's why I was kind of late. I don't know. I've reinstalled this version of Nightly like 3 times already. I also changed the version of Nightly, and if nothing will get the PCB editor to open. So I do not know how much I'm going to be able to do. If anyone has any idea, let me know. If anyone's had this happen, I can open up the standard 5.6 regular version and it opens fine. Hey guys, hopefully I can actually do a stream. Um, I do not know, and it's also what's interesting is it has nothing to do with the current version of the board revision, because if I revert back, so if I exit out of everything and revert back to the change that I had after the last live stream, that oh okay, so now I'm back to the changes that I had on the last live stream, and still won't open the PCB. So if anyone has any ideas, please let me know. This is obviously one of the issues with the nightlies, but it seems to be just with this computer, because I did it on my computer at home this morning and it was working fine. And since I made changes, I won't be able to do anything with the prior version. So I guess I can try downloading one of the previous ones, and I'll just have to redo what was on there before. So let me try. Hey Dustin, how's it going? So this is the one that I'm currently using, so I'll go back to the prior one and see if that does anything. What if you save it with a different name? I actually tried that. Not saving it, but I installed it into a different directory, and that didn't work. Here, in the meantime, my monitors got swapped, so I'm gonna switch which one OBS Studio's on. So give me a second. Okay, now we're back on the correct monitor. What web browser? It's called Vivaldi. It's a new browser that I just started using. It's pretty fantastic. You can customize like everything on it. There were spaces in the directory path. I don't have any spaces. I mean, I guess just program files, but I assume that's okay. I mean, this is where it's been installing so far. Oh. Claude thinks, I think that's how you say your name. If not, sorry. I appreciate the kind words. Hopefully we can get this stream going at some point. Always the joy of using nightly builds. And I figured I was safe because I had tried it, like I said, this morning on my work computer, or my home computer, but apparently not. Guess let me go. Okay, so this is my new directory. Let's see if this works. Dang it. Okay. So it doesn't seem to be tied to the specific version. It seems to be tied something with my computer, which is odd because all of the prior ones have worked. Like this is the latest build. And I don't have any of my other nightly builds. Everything I have is just the is that no, that's a super old one. Um it's weird how it just like hangs too. And I tried making a brand new project and opening that one up. And I could open up the schematic totally fine, but it's the second I go to open the PCB that it doesn't work. I wonder if I can open up. Does it open? Yeah, that's Conrado. That's exactly what I was thinking, that it might have been something just with this, but no. It's, oh, can I launch PCB New separately? That's a good idea. That I have not tried. So this is in the same build. Okay, so... Oh, no, Oh! It's literally goofed because I'm on a different... Because my monitor's set up. Oh, are you kidding me? Okay, who knows the trick for that? I know there's a way... I know you can Alt-tab it, but how do you actually bring it... Oh, there we go. Okay, so let's see if that was the issue for the other one also. That would be fantastic. There we go. What's funny is, ironically, I don't know if any of you guys have been following on, I had watched from Linus Tech Tips, but from anyone on the new Windows 11, that's one of the things they actually fix is whenever, oh gosh, that got angry. Whenever you change monitors around with Windows anything up to this point, it does super weird stuff like this, and supposedly Windows 11 will actually fix that. But I guess we'll see. What's weird is now I'm back to how the original monitor was, but anyway. Okay. Now we can actually get started. Alright, so, where we had left off is, I guess, mainly doing the power distribution and then roughly setting up how the bottom traces. I deleted the latest commit, did I? No, I just undid what I had. I'm back on the main one. Yeah, because this was earlier today. So a couple things that I don't even know if I have Discord up. Speaking of which, join the Discord if you haven't already. I want to show one person in the comments had a really good idea or a good thought, and then someone who had posted on, I think on YouTube videos here, yes. So they're both along the same line. So what the person in on YouTube said, and sorry, I don't remember who said it, is these are too close to each other because if you have, I don't have anything here, but some like dongles will be pretty big and it would take up space and they would get in the way of each other. And then what TS Manual had is having it more widthwise, which lets you put all of the power stuff up top, and then you can just have all the USB side lower. So both of those kind of accomplish the same goal, But what I am thinking to even more so maximize is if we were to take this and rotate it over here. That kind of wastes a lot of space here, unless we do it like that. So let's see how this looks. And before I do that, I'm going to widen up my grid. Try to keep this somewhat consistent. Because how far off are these sticking? 1, 2, 3-ish. So 1, 2, 3-ish right there, I think. Try that. And that. Where's my other edge cut? Oh, my edge cut's not on with my pour. It should be. Okay, so if we do something like that, and now if we move all of this, see that one? And then if we widen up the edge, I'm thinking that might give us enough space. So, and something that you can sometimes do is if you make the grid origin at a point where you're messing with, and then make your grid really coarse, you can then like 5, 10 millimeters. So what if we do 30 total, so 15 on each side? See what that does. So 5, 10, 15. So that gives us now 30 on both sides, and now we can move Z to change back our grid origin to 0, 0. And then drag all of these. That'd be something cool in a later KiCad version, is to be able to drag all of these at once. Because obviously you can move everything at once, but you can't drag like the actual corner. So if we do something like that, and now I believe these were dead center, so I want to keep these consistent. So maybe we move them over 10 on each. See what that does. And something I do quite a bit, I don't know if I'd mentioned it in my last stream or video. Oh, even the 3D viewer got moved over here. So goofy. I use the 3D viewer quite a bit because it gives you kind of a better overall view of how everything is. I don't have, obviously, many of these set up for 3D models, but it still gives you kind of a better view of how the actual board looks. And yeah, I think that definitely. Oh, 1 second. Okay, and okay. So yeah, I think that probably solves the issue of having the dongle interfere with another one of the ports, and it gives us a little bit more room to maneuver the power. The one thing I do not like with what was TS... Oh, Discord. One thing I don't like that he did is he put the power coming in from the left. I still want that to be on the top because the Type-C connector is going to be from the top, and I'd like to keep those consistent. So I do want to adjust it from there, but overall, gist of it seems pretty nice. And obviously, if anyone here, if you guys have any suggestions, let me know. So now, with our power here, he doesn't... Oh, he had the USB-C on the left side. I was going to say, this kind of actually won't work that well, moving all of this way over, because that doesn't really allow us to... Yeah, I don't actually know how much that helps. Let me know if you guys have any thoughts. I might just, without taking up too much time just twiddling our thumbs with this, we at least have kind of the gist of how the 12 volt and 5 volt side is going to play out. I think we might be better off now working on the USB side, which, yeah, that's what I'm thinking. I pull this up, and I'm gonna put this on my other monitor. I wish YouTube had a better way to see the chats. It kind of gets all clustered on my other monitor, but I guess it is what it is. Oh, that's a lot. Okay. So what all else do these have? So each one of the USBs have these sets of the USB, the TVS diodes, and then they also have some bulk decoupling on the V-bus, and then from the V-bus, they all go to the V-bus monitor. So I guess we can start with some of the roughing in on the V-bus side, just because we'll have to sort that out anyway for the differential pairs. So we might as well get those sorted in the meantime. So J6 and J5 both go to this one, which is here. And then this has some decoupling on the output side. And then each of these, like I said, also has decoupling. So there's a 5 volt TVS, C63, or 73, and 74. We can move all those there. And since if this is in an enclosure, essentially this is going to be the only part sticking out. So there's really no reason to not want to put these over here. Oh, one thing we're going to want to do, we don't want these two to be tied to the same V-bus. We want to have these two so we can bury it over here rather than having to connect over on this side. So let's do that now. And then this is where having the hierarchical sheets like this make this such a breeze. So if we connect, so V-bus 1 is J5 and J6. So if we just swap these two, that should work. The only thing I don't like is it messes up how the labeling is here. So maybe what we do instead is just move this one, and I think that works. So I'd like to keep the naming semi-consistent. Oh, now our TVS diodes got moved. Okay, but let's see if this at least worked. Yeah, so now these two are tied here, and then the other V-bus monitor should be tied on this side, yes. So then we'll just have to live with having to adjust the TVS, which this is a great example of why I do not... one second. This is a great example of why I don't do all the routing at the start, because you end up having to make changes like this, and if all these TVSs were perfectly routed, we'd have to redo all of that, which would be quite a pain. Trying to think if there's any other way. Yeah, we'll just redo those. So this TVS now goes here. Oh, wrong one. Okay, how... Oh, they are on a different layer over here. I was gonna say, that doesn't make any sense. Okay, so now if it goes like this, these two match up perfect. I say, going crazy here. Okay, so those are lined up, and now those two will go over there. Now, let's grab other set. Okay, something did get mirrored moving these, which I don't know why. Huh. Okay. I guess plan B. Let's just do and swap these because that's going to be an absolute pain to swap all of those. Now let's see how this does. So now all that should have done is moved these two here and grab this. So now B bus 3 there and B bus 1. Oops. No. So V bus 1 needs to be where V bus 4 is. V bus 1 needs to be where V bus 4 is. There we go. Okay. So now all of those should be good. Okay. So the biggest thing I am thinking with the V-Bus power IC is we don't want to do anything that will interfere with our differential pairs because that is way more important than us doing the actual power side. So I'm thinking it might make sense to put both of these over here. Because if we put them, mosquito. Got him. Gotta love living in Florida. Um, oh crap, these are still, the TVS diodes are still swapped. So it should be V bus 4 and 3 there. So 4 and 3. Hey Pedro, how's the weather down there? Probably about as hot as it is here, huh? It is quite oppressive right now. Okay, let's see how that did. Okay, TVS diodes are good. They're all going straight up, and now let's double check. V-Bus. V-Bus is good there, and VBus is... How does the VBus keep getting swapped? I don't understand that. Okay, VBus 3 is good. Now VBus 4 and VBus 2 need to swap. Okay, let's see if that worked. So now that goes here, and then 3 should be over there. Okay, perfect. Okay, so like I said, this can either go... I guess let's first work on the bulk decoupling on the USB side. So each of these have two 10 mics. So we can put... Oh, those are the two for the actual hub side. So for this, I guess for now we can just throw them there. Kind of grouped them weird. Even though they were on separate sheets, it didn't really group them all together. Just kind of odd. Not that it really matters for this, but it's probably going to make the actual USB and differential pair routing a bit of a pain. And the TVS diode here, of course you want it to be close to where it comes in, but since the USB spec dictates on the downstream side, there's not going to be more than 5 or 10 microfarad of capacitance. As long as it's not a super long cable, I'm not expecting this to take a very large hit, so routing that probably doesn't have to be perfect. But, of course, the better you can get or the closer you can get, the better. Here are these. See, this is where the question's going to be is because these do not interfere with the differential pairs at all because they just go up. The differential pairs on this side are going to be going up here. So we want to make sure this stays out of the way. So I wonder if we have enough space to throw everything down here. If you have an EDU, yeah, but that's quite illegal for me considering I graduated quite a few years ago and run a business. I wish I could do that. Although, honestly, especially with doing so much on YouTube with KiCad, I mean, I've thought about getting it for work and to have our guys use Altium, but honestly, I would end up forgetting so much about KiCad, and there's obviously a lot more people, or at least I think there's a bigger pool on YouTube just because KiCad's obviously free, where Altium, I don't think you're going to have quite as much, but yeah, if you are in school, you can certainly get that. And then, like, what? They have Circuit Maker, I think, which isn't quite that expensive also. Okay, now let's grab these. Yeah, grouped them all nice and consistent, just kind of in weird orientation. It's like there was supposed to be something else around them. Okay, so this is probably how these differential pairs should be where this one is a little bit higher up. So maybe let's do this first. Or wait, no, that's just because that got rotated. Yeah, I think that's fine, because if we were to grab this one, yeah, so that's still good. So then we do have space here to have these. Okay, so you know what I am thinking works is if we have both of the V-Bus controllers here, and then they just run up underneath here, and then that gives us a ton of free space for this. So let's see how that works. And now's where I'm gonna have to either remember or see how we're going to do our stack of what is going to be on this power core. One thing that I kind of try to do is even on routes that most likely will end up being on a different layer, I'll usually start still on the everything being on the top layer, just because the more you can route without them interfering with each other, the better. Oh, Dustin, how did I miss that? That's terrible. Yeah, that is certainly true. Problem is, because I'm moving all of these as a group, it's kind of hard to get them all on that same plane. But there, that should be good. And then I guess we just have to decide which plane. This one's probably good. Because mounting holes, if this were to have them, I guess would get extended here so that we can always do if we need to. The unfortunate part about this project, and I've mentioned this on Discord a couple times, is with the chip shortage, I did not order all of these in advance, all the parts. So a good portion of this board is completely unsourceable with parts, but I guess that's just kind of par for the course. Okay, so V-Bus. So I'm thinking that will route here, then this has to crisscross. So let's swap V-Bus 2 and 3 on here. That gonna mess up our decoupling? Maybe, but it won't be that big of a deal. Hey, does anyone know, is the backwards back annotation being able to change on the PCB and having it update on the schematic, is that implemented yet? I know that's going to be on it, but I wasn't sure. Oh, it didn't mess up the caps, that's good. But I don't know if it's actually implemented yet. And I like having the caps closer here rather than here, just because then that's a lower impedance path, and then this does have its own caps here, so that kind of gives us the best of both worlds. What is that for? V-Bus 1. And to what, Dustin, what you had said, that's honestly one of the things that I am pretty bad at, is keeping everything consistent on different blocks of a layout. That's something that just kind of takes time to get everything aligned, but it's certainly something that is important to have done for sure. Okay, so let's grab these, and as always, this is not even remotely going to be the final route, just something to get us over here. And also, like I said, most likely won't even be on this layer, but if you can route it on all on the top layer, then you're gonna have less overlaps anyway. So it'll typically be a better route no matter what. So we throw these and then join that. So yeah, I like this. This keeps the power completely away from all of our differential pairs. And if we have the 5-volt supply for these on the bottom layer, or on our power pour, which I assume we will, there is literally zero interference with anything going to those USB lines, which is, of course, on this board our biggest priority. So now let's grab our other power switch. So this might be a little non-symmetric just because obviously the V bus is going to be on a different side here. So if we were to do them completely symmetric, we would interfere, have to put this over here, which makes it for, like I said, a little bit higher impedance of a path. Oh, I don't like that. Even if it is just for now. Yes, definitely. Yeah, it's kind of funny. It's like, and also as a side note for work, I don't do a ton of the layouts. We have a dedicated layout guy. So being able to, like, I've picked up, like you said, just kind of doing this stuff, people who notice things, it is very, very useful because more often than not for work projects, I am just reviewing boards and not laying them out. The biggest thing between like a person who's good at layout and someone who is amazing at layout, like Gary, who does ours, is how quickly you can do it. It's like watching him do a complex board like this in like a third or a quarter of the time that I do. It's pretty impressive, and I think that is really the biggest difference between someone who is amazing and someone who is pretty decent. So here's another thing, maybe making it non-symmetric. So I'm thinking if we route this up here, that keeps it completely out of the way of our power side. And the beauty with this being a pass-through is we should be able to rotate this the other way around. What am I doing those 0.2 millimeters? I forget how someone said how I select the whole trace in one go. That's something I really don't like in this version. They should have kept that. I liked that sort of lazy selecting, but I'm sure as anything else we'll get used to it. Will there be room to get both? Yeah, I think so. Oh, so my rotation was correct the first time. All right, and then just to reiterate, these are not the final differential pairs. We'll go over doing that probably not for a video or two, but deciding using like the stack up information from whoever's doing your manufacturing, what size the trace is and what the spacing between them should be to get the impedance between the two that you need. But that's pretty simple. Okay, so now, what if you had selected vertical USB? I don't know. I don't think it would have affected it. That's more of how the final unit is. I'm trying to think out in the back in the assembly line, I have do I have anything here? No. I guess for functionality that might have been neat because then you can have like a flat box and have the USBs coming from the top instead of the side. But as for making the layout easier, I mean they would have been essentially the same no matter what. Where stuff like that can sometimes start to matter is when you start dealing with the type C, and these are all the type A, type B up here because they are surface mount pads, and sometimes those can be a pain to solder, even like using automated equipment, and vertical versus horizontal can make that easier or harder, but it's still usually not a huge deal. Okay, now let's move these and then make sure we have the correct caps. Okay. Why are these so big? Oh, they're only in 805s. I guess that's funny when you, everything on here is so small and everything else is 0402s. Even like an 805 looks absolutely massive. Put these, throw right here. Oh, why is pin 3 over there? Oh, that's for the, current limit. That's annoying for it to be there. I mean, again, we'll be using multi-layers for it, but still kind of a pain. And then one thing, if you noticed, I almost did, but is a pretty big no-no, is with stuff like this, you don't want to ever do that. It violates IPC guidelines, and it, unlike some IPC, that one actually makes a lot of sense. So if you are assembling boards and you didn't do the design, so you're a CM and you just are assembling boards from a client, you don't necessarily know all the inner workings of the board, but if you see these bridging when you're assembling them, they don't pass IPC. Oh, and look, I did that exact same thing here. It's an easy mistake to make. It makes it look like it's shorted out in a bridge between these, even when they're supposed to be, because if those are here, first off, most likely the fab will not be able to put solder mask in between them, so it's just an open piece of copper, and that solder is just going to wick right through. And then the other thing is, when it wicks, you have less solder on each of these pads, and there's no actual terminal here, so it makes it a little bit weaker. So that's something you do want to keep in mind, and try your best not to. For whatever reason, it's kind of hard to never do it because they're always right there. And it just did it again. Oh no, that was the one I did as an example. Never mind. Okay, so now let's get the other one. See, 77 and 78. And if you notice, I don't do a ton of my... Oh, we're going to have to swap these. Crap. I don't do a ton of my routing with the rat's nest on. That's totally a personal preference. I just find it to be really, really confusing. But if it's what makes more sense to you, then by all means, go for it. Okay, so we have to swap B-Bus 1 and 4 now. 1 and 4. But also, that is one thing, like I'd asked a minute ago, if anybody knew if, in this nightly, if KiCad had had the back annotation. What's funny is some people think that that's like the biggest deal breaker, and that's like, oh, you need to use Altium because it has this. I honestly really don't find it to be that big of an issue, because like I just swapped out how many traces or how many nets on the other side. It really doesn't take that much time. I mean, it certainly is a nice to have, but I wouldn't even consider it remotely like a must have. But we'll see. Maybe if they implement it well, it'll change my mind on it, but we'll see. Yes, good point, Dustin. Absolutely. This is totally just because it looks good. I would absolutely do 45s to all of that, and not do the T's. I try to never do a 90-degree like that. Um, Back in the day, it's one of those things. Oh, you get an acid trap and whatnot, but that hasn't been an issue ever in the time that I've been in the industry. Back when they were doing it 20, 30, 40 years, apparently it was a pretty big issue, but it's nothing you really have to concern yourself with. Something I'm going to do a video on at some point, and the main reason I haven't yet is because I just haven't gotten everything written out. I need to. Is just kind of the design rules that we use for just general use. Because something you hear all the time, it's like, oh, it depends on your fab. It's like, well, yes, but if you're designing a board and you don't know necessarily who the fab's going to be, or maybe you're using a different one for production and for prototyping, what are just kind of some general design rules. So I want to get something in that. And where I was going with that is Fab 3000, which is what I use for DFM and DRC stuff. I disable the acid trap check because, again, if I see it, I'm really going to ignore it. Or I'm going to ignore it anyway. Because it's just annoying. It's like if you look at this, like on the mask, like not on any of these, but when we start doing some more traces from here, when you see how some of the layers will come out from a pad, it'll form a acid trap in and of itself, and there's nothing you can do to avoid it. So it's just kind of a pain. Oh, that almost fits in there. Okay, so that is now the power side here handled. So presumably at some point we will have the 5-volt down here that feeds all of these power, so we don't have to have anything interfering with our differential pairs. So I guess now it's probably time to start working on the downstream hub side, I am thinking. So what is all this? That is the switcher for the 1.15, and then the LDO for the 3v3. Those, I think we ought to wait until we sort out the rest of the power side. So I'm thinking probably to start on here. And this is where the back annotation might come in handy if we had it, because we're going to have to figure out which orientation will feed these the best. Yes, and there is a 95 or a 90 degree. I mean, if you do it exactly like this, the thinking is at least on the outer side you're good. But yes, of course, in here you still have the 90. I do it solely because it looks a lot better, and that's the only reason. Electrically, this compared to a straight 90, I don't think has any difference. Some of the RF guys, when you're in super, super high speed, would say that it still does, but any normal speeds, I would say absolutely not. Okay, so I'm gonna try. So something that helps when you're trying to get just like the gist of the layout, if you just delete a lot of the other parts on the board, you can get a better feel for where the important parts are. So we need to figure out what orientation is going to feed these the best. And likely we're going to have to adjust the nets on these, but we need to at least see how. Okay, so this way at least gets it gets these here perfect. So if we were to swap four and two, that would unwind those. And that actually might be perfect. So if we swap 4 and 2, let's see what that does. So 4. Whoa, did I move that? No, this one was off. Whoops. Surprised nobody picked up on that. Okay, no, we don't want to do VBus because we've already messed with all that. So if we do 4 and 2. This is an example of having that back annotation. There's no way you're going to be able to swap all of those traces quicker than what I just did here. I mean, maybe. I doubt it, though. Does routing in a circular pattern make a difference between a 90 or a 45? I don't know what you mean by circular pattern. We're just referring to if you have to have a trace jut out. Circular, are you saying not angled at all? You still typically nowadays will do. Aww. It brought all those back. That kind of scared me. I'm like, where did all those come from? Okay. Yes, so that fixed those. Now, there. So those go here. So perhaps, but I don't like how these are on the opposite side. They should be on the inside here, which means I'm going to have to redo how I had it. Where's the upstream side? That might matter too. Okay, the upstream side's here. Wait, is it? No, the upstream side's there. So this might be a candidate for having the hub at a 45-degree offset to get kind of the best of both worlds. Like a semicircle. Yeah, like I was saying, you can do roundish traces, or semicircle, but the issue with that is it just makes keeping everything organized a lot yeah, grows at 45 angle. That's exactly what I was thinking. So let's try, I don't know if it's negative 45 or positive. Let's see what that does. Yeah, that's the right angle. So now we're just going to have to swap all of these. So we would want 3 to go where 1 is. So 3 to go where 1 is. Now I remember it's going to bring back all the other footprints. Okay, so that gets those now. Now the next one is 2 and 4 swap. And that's going to take such a long time to get used to. And you can just drag without selecting it. Okay. There we go. I think that does it. All right. So now, do we gain anything by having it at a 45? Can I send you a project for you to review? Intermit Tech, thanks for joining. Brandon, so since a big part also of what Microtype Engineering as a company does is reviews, I basically have a thing to where I won't do reviews just for like free like that unless I put it on as a video. And if you check, I think even in the description of this, I have a link to submit reviews. If it's something like that, totally, I have no problem with it. If it's something that needs to be outside of it, then that would probably fall into more of the work category. But certainly, if you want to do either or, just let me know. But yeah, I'm thinking that 45 helps because it makes these a little bit shorter at the expense of making that a tiny bit longer, but not really a noticeable amount. So now what I want to do to keep this centered, why do I not have this at any sort of origin? I should. Okay, so now the edge is at 113 point, no, 99. That's really unfortunate that's at 99 and not exactly 100, but that would screw up these. But I can't have that at 100, or at 99. Let's move that to 100. Worry about that later, I guess. Okay, so it's at 99, so to get this centered, 99 divided by 2. So now that is dead center, which should be between these. It seems the fourth unit is having a misplaced hierarchical pin. Did I miss another? I thought I got them all. Ah. I knew someone would catch that. I don't know how that happened. It obviously, yeah, it happened on all of those right there. That's funny. Would have figured it out sooner or later. Alright. So... Oh, it's gonna automatically... Yeah, so I guess we probably ought to get this on a decent grid while we can, because it's gonna affect how everything else grabs. So... I guess for now, let's do 100 and 114. See, like I said earlier, this is something that I struggle with, keeping everything on a nice clean grid. Okay, 100, 0. That should still be 0, 0. Yes. Okay. So now this goes to 50. And now 1 through 3 have pins in tight pair, and the fourth... Yeah, that's what I was thinking. So now if we want these to be centered off of here, I guess first let's make sure center, yeah, center. So what, 100, that's 50, so 25 and 75. So what we can do is move this to the left by 3. So everything on here move to the left by 3. Was that far? Okay, so we're not going to be able to have those then. So we'll just keep them centered equivalently. So that's 28. So that's... So that's 22 off center. So then the other one should be at 72 to keep them proportional. Really? I'm guessing I mathed completely wrong. 17. Yes, I did. So then, are they good? 24, 26. So it needs to go over by 2. There we go. Okay. Okay, so these are now good. I guess we can make sure the Y is good. So 103.5, 103.5. I am using, yeah, it's the nightly latest as today. So there's the release build. Now let's make sure these are accurate. So Y is 106.25. That's still that far off? 99.35. How is that far off? It's not. Oh, so that means the center point must not be dead center on this, which means all the other stuff I did is probably off now. 7.65. No, it is. Got me. I mean, it's obviously the way that I rotated it, but I thought that it kind of took that into account. Apparently not. Okay, we're off by 0.05. That's fine. Okay. All right, so now that is solid here. Origin point, yeah. That's what I'm assuming, and it's when I rotated it. Okay, so now let's put all this crap back. Okay, so what we can do before we start doing all the differential pairs, because they should be um um what I'm debating on is, so on the hub there's a decent bit of peripherals here that also need to be set up, and like some pull-ups and stuff. It's like a 50. I guess we should probably do at least the rough differential pairs first, because that's going to be more important. And then just keeping in mind, obviously, we have the AC blocking caps for each of those. So I guess we are fortunate, because this is the USB 2 side. We're kind of fortunate that those connect directly and not needing the blocking caps, or else it would have made adjusting all of the orientation of this a lot more difficult. As for picks, what happens if this goes back to 90? Because I do like to avoid doing these at an offset, solely because it makes placing all the parts, everything else, a lot more time consuming, because you can't just put them at an even, like for the resistors and stuff, either 0 or 90. They have to be all offset if they're aligned here. So that goes there, that goes there, that goes there. Yeah, I think let's try it like this. It's going to save a lot of time down the road. So now let's just go ahead and roughly, I guess we can do the differential pair router just to save some time. But Oh yeah, I ran into this before. It doesn't neck these down for some reason. Oh, what's our spacing here? Why is there so many origins? Weird. Origin of the mask and everything should be identical. I have absolutely no idea. So it's a 0.4 pitch. So what is our... Well, it looks fine. Yeah, I forgot. This was an issue I had messing with the nightly last time. Okay, so what is it not like? Do I need... I'm at 0.12, maybe? Yeah, but if it was the differential pair gap, then it would have worked when I did them separately. So maybe it's just all of this. See what that does. Yeah, so just needed the clearance better. And again, we'll be doing the differential pairs, the correct width and everything a little bit later. A little bit later, probably in a couple videos. I swear this is the project that will never be finished. But doing the live streams, I definitely don't mind. Doing all like the schematics and the videos and doing all the editing, that takes a lot of time. This is way more enjoyable. And now for the AC blocking caps. I do not believe that there is a preference for which side they are closer on. Because since they block the DC side no matter what, it typically isn't going to matter which side they're on. If it's for like something we're doing right now is some SD RAM, and those have to have series resistors to help block reflections. Those it matters where it is on the single-ended side, so that or the sending side. Let me start over. On a one-sided communication line, so if it's not data, if it's like an address line, you want the series resistors to be on the sending side. If it's a bidirectional line, so it's data going back and forth, you want it to be dead center. So I don't think it's going to matter, but I can check on an app note and see if there's any thoughts. Differential pair, yeah. What's weird is it seems almost like this the differential pair router in the nightlies is significantly worse than in standard, which is odd. Well, I'm glad you like the live streams better. At least for this. See, like this crap. This is obnoxious. Let me, I guess, just change these just a little bit. Oh, not differential pair. And then this is stupid. Like, it's a pain to change these. So let's do 1, 2, gap. Oh, clearly I did not put a decimal. No, it did. Yeah, I don't understand why it's not letting me route it here. Because this does not happen on the stable version. Because if it violates it, it at least lets you get to the nearest point to be able to start. Because the issue is, since this violates this... There, now it does it. Because since the spacing right here is too wide, it should do it to combine them. Yeah, man, this is not a good experience. Hmm. Yeah, and it's not even letting me click. Which is weird because I just changed the... Oh, now it might be... Who was saying that? MSCNC. I think that this might be now what you were saying. Yeah, and they changed the entire board setup page also, so this is completely different. So where was it? Differential pair width. Yes, so that's probably what it was. So this needs to be 12. And yeah, that was probably what it was. Yep. Which again is weird. It shouldn't let you adjust it and be able to start routing if that's going against what the DRC is. But I digress. Okay, at least now we're able to start that. Good evening, Johnny. The only thing I could think... Yeah, but Mickey, keep in mind, these will be blocking the DC bias and letting AC down, and it's coming from a TVS diode. But yes, ultimately, that's why I'm starting them where I am. I am leaning towards what you're saying and having them on the output side. Okay, now at least this is working. That was painful. Okay. And again, for anyone who might have just joined, I do all that, and now we have to swap these. Dang it. Okay, so swap 5 and 4 on here. What were they called? SP3, so the negative and positive. So this is where it's going to get a little hairy. Actually, no, that's convenient swapping them here as well. So that works. So just the downstream and upstream. So these two. Now this is where being able to adjust, do the back annotation from the schematic would be really helpful, or from the layout would be helpful. Okay, anyone remember how do I delete an entire route without doing them all by one? Because this is going to be a really big pain. I don't know why they changed this. Is it Alt? No. Should go back and check the comments of my last stream. Someone told me. I just forget what it was. I do not know why they changed that. No, intermit tech. That's how it was on the non-nightly. Wait. Oh, because I didn't swap these. I was gonna say I already did that. On this new version, it doesn't do it. So look, everything is deselected, and if I hit delete, it just does that single trace. That's how it used to be, and that's how I wish it still was. There's a way to still do it, but I don't know what it is. That's exactly what I want those differential pairs to look like. That's normal, though, with any ECAD, is they want to keep the differential pair spacing at all cost, when in reality, doing something like this will typically be better. Yeah, there's something you press, it either selects all of it, or it just does the same feature as when it's unselected. So it works fine. It works the exact same way that it used to. It's just with a different setup. Okay, now we need to get these. And I don't know if it's just me, but it looks like in this nightly, when you like highlight one of the parts, it's way harder to see what else is selected than like in the other versions. It's probably just me though, but okay, so all of these are going to be swapped. So E and N. Do you guys like the streams at this time versus how I normally have been doing them, which would start in an hour and a half? For me, this lets me get done like before I have to go and have some food, so I'm way less hungry during this. So I definitely like this time a bit better. But I'm sure the other works better for some people's time zone and vice versa for this. So presumably I can swap them and do some at this time, some at the other time. It said press U. Okay. So is it U to select? Yes, that's it. You did exactly what I said, checking the other. That's funny. I appreciate it. Which is so stupid. It's like, why would you? When you hear U, it's like unselect, not select all. You would think it'd be like A or something. I don't know. Oh, A changes the fill, I guess. Which is weird. Never knew that A did that. That's pretty funny. Okay, so those are those diff pairs. And then presumably we're going to want to slide this down as close as we can, but I'm kind of holding off on that just in case it makes something else upstream not work as well, but we'll see. I am pretty happy, honestly, with how this is routing. This is going to be pretty straightforward, I think, on the USB side, which is to be expected with TI or Microchip. They lay out their traces in a way that makes quite a bit of sense, usually. Currently it's 22:23. Perfect. Awesome. Okay, so now here's our first. So we're going to want to swap this, I believe. So that'll make this a little bit harder. So yeah, this will have to weigh because if we keep it here, it makes it easy to route from the connector, but it makes these have to crisscross. So one way or another, they're going to have to crisscross. I think I would rather these cross, because here we're going to be kind of tight just because we're by the connector, and with these being TVS diodes, any sort of via here is going to add the chance that if there is an ESD event, it's going to radiate out from that via. So I'm thinking we'll just suck it up and swap them out over here, depending on what it looks. Oh, wrong one. As much as I am complaining about KiCad 6, I really do think that this is going to be definitely not as big of a jump as 4 to 5 was, because 4 to 5 allowed it to be used in like commercial settings. Before that, it really wasn't. So it's definitely not that big of a jump, but it's going to be a pretty big jump. I'm pretty excited. What I just like is so many of the like discontinuities between schema and PCB new are gone. Like they're trying to make them more like streamlined, even if it's things like the U type stuff that I don't like. I still like that they're doing it because it gets confusing going from doing a schematic to doing the route, and like half of the shortcuts are completely different. So I like having them a lot more consistent. And that is one of the biggest, I think, real complaints about KiCad is how vastly different the two editors are. Yeah, worry about that later. Hey, why does capital V not let me choose layer? Because that should be on signal 2. That's exactly how I want my differential pair to be. Oh, are these swapped? No? Why is it not letting me do that? Again, that's something to worry about later. Personally, like letting the new settings. Yeah, I agree. Like I said, I'm complaining a lot about it, but ultimately, I think it is a big step up. It's just like anything. There's a lot to get used to, so I think that's going to be the biggest thing. Like again, like anything. Okay, that's good. Now, so which side do we want this on? That looks good. And also for people who are just stopping by, if you haven't already, join the Discord. The link is in the description. We're getting up to like I think 400 people, 500 people. It's insane. Like never in a million years did I think that it would ever get to that point. Super cool that it is though. Maybe there's a tiny bit of trace. Yeah, there probably could be, but again, I'm not too bothered about any of that because we're not even using the right trace widths for the differential pairs yet. Because I kind of want to make sure that's on a stream where I can start with it, because using some of the calculators and stuff can be kind of confusing, and I'd like to make sure I like devote enough time to people have questions. I can kind of go through some of it, because that's a super big thing when you're doing differential pairs. Now, why are you not letting me do that? Are these spaced different? Yeah, I think one off. Oh, and something I completely glossed over. So if you recall, the stack up is signal, ground, signal. So the ground layer, so layer 2, which is yellow, that will be the reference layer for all of our differential pairs. So anytime we do a layer change, we have to keep it on that same reference. So the second layer, so the yellow one again. So by just jumping there, all of the returns stay on the exact same, or all of the reference stays on that exact same return layer. so you don't have any discontinuities. If this were to jump down to the bottom layer like it wanted to at first, then it's going to have to jump through not only more core, it's also going to have to jump onto a completely different reference, which you want to avoid as much as you can. If you do have to do that, which we're certainly not going to have to here, it's always good to have stitching vias all around here to be able to make it, and obviously make it look a little prettier, but to allow the return to jump through those, because if not, it can be a bit of a pain. So that's the biggest thing when you're doing differential pairs or anything high speed. If you are changing layers, you want to never have to have the return change from the reference plane. So by keeping that ground layer completely free, you can make sure that you don't have to worry about it. Where is it at? Oh yeah, right here. I guess it do that. It's so funny. I mean, I know why it does it. It values keeping that space the same more than actually how the route itself looks, which I guess in its defense, that's probably the way it should be. Should you separate power and ground planes? So this is kind of a big topic. Ultimately, if you can have your choice, you want to always force your reference onto what we call ground, but it's truly just a reference. So you can do it on a power plane, but it becomes a little bit more interesting. So you definitely want to keep it on a ground port if you can help it. But that's honestly that's a topic for another time, just because it gets pretty involved. Because you tend to have more common mode noise on a power plane than a reference. Not to say you don't have common mode noise. You have common mode noise on any port, including your ground reference, but it tends to be a bit less, and you can have a better idea of what the potential is there. Okay, so that is that. But ultimately, unless you are incredibly constrained by cost, in however many boards we've done, we've never had to use power as a dedicated reference for anything high speed. So it really is something that you can typically avoid. And we've gotten lucky with these not having to swap over. So yeah, we can move this down some, but probably not a ton. Yeah, this would be a little better on a 45 angle. So maybe what we do is, again, since these are all just placeholders, we put all of the decoupling caps and everything else around here, and then maybe we delete all of these and then rotate that whole thing as one, and that might make it a heck of a lot easier to do the to have all those already pre-placed at the odd angles. We'll see, though. I don't think it matters either or, but I do think it's a little bit better at a 45. It's just funny to see, though. Ooh. Let's do it over here. So another little, doesn't really matter because either or would be pretty short here. Is if you're jumping over a set of traces like this, you ideally want to do it at a perpendicular to minimize the time that you're crossing. But for something like this, it's not a huge deal either way. So one thing kind of along those lines that probably won't be worth it, but it's going to be something to consider, is the way this is set up, and I might look at some of their app notes just to see how they've done it. I'm assuming they do it like this, but we do have a lot of these differential pairs near each other, so we're going to get some sort of crosstalk. There's a pretty big distance, so I don't think it'll be a lot, but an option we could do is have all of the vertical traces on a different layer and all of the horizontal on another. So signal 1 and signal 2 to just kind of help alleviate it and not have as many 45s. So this would go straight up 45 and then over. It's something to consider. I think we'll be fine keeping it like this, but just thought I'd mention, if you have a bunch of signals in an area, that usually works pretty well. You do it like, oh, how did this one get all messed up? This is on the inside. So this is like this one where we should have swapped them. This should be on the other side, and this should loop around. But not to be repetitive, that's why I do this, where I just mock up all the traces. It's not worth it to change it right now, but certainly when we do this for real, we'll go ahead and move that. Hello? Um, See, there's just weird little bugs in this nightly that really aren't in any of the others. At least not that I've seen. Okay, so that is all the downstream differential pairs routed. Look at that. Okay. So yeah, rotating this at a 45 doesn't placing differential pairs. Yes. And I don't know if you had mentioned that before I mentioned what I was saying. Yes, I mean, no matter, no ifs, ands, or buts, this does. But another thing that I didn't mention is the way differential pairs are, having the negative and the positive side on an offset edge. It makes crosstalk as a whole way less than if these were single-ended pairs. So like that SD-RAM that I was saying we're doing in this other project, you can have a lot more crosstalk with that because they truly do share the same reference plane. It's not as significant here, but yes, that absolutely there will be some, but you can't really avoid it. At some point with these, you're going to have to cross because either if we were to flip-flop these, then it would have to cross here on a different layer. The only advantage I guess you get here is you only need one set of vias instead of two sets because you can start on the other layer and then pop up on the top layer. So maybe that is the way we should do it, just to alleviate one set of these, but you're still going to get the crisscross. But yeah, good point for sure. Okay, so now, so this hub uses 3v3 and it uses the 1.15 volts. So we are going to have to figure out. Oh yeah, and this is the only IC I've ever seen like this. So I don't like, yeah, this the blending that they do on this is a little strange. That's gonna take some getting used to. Because I know they have like all the different ones, which I normally will do hide at least, or I guess dim's pretty cool. Um, Yeah, and these colors are different than what I normally use also. Um, so what's interesting is this hub has 0 ground pins. So you can see like this one, pin 24, it looks like a ground pin, but it's not. It's just a pin tied. So all of the ground has to come through here, which is absolutely bizarre. I've never seen that before. Normally you would have your 3v3 with ground, 3v3 with ground. It is X. So that's just what it shows NCs on here. Yeah, Brandon, exactly. That's exactly what I was saying. Anything like that, you have to worry about it more. That's the beauty with differential pairs. So what's really strange about that is two things. One, obviously this is a floating ground right now. We're going to have to add, and I'll change the footprint to have. Actually, I guess we can almost do it uh, without and just having vias in here. This is another thing I'm gonna look at the app note just because, like I said, I've never seen this. I mean, I get why they did it. They ran out of pins on here, but that messes with your signal integrity for sure because now your decoupling caps have a little bit longer path to go back to the IC, but it obviously isn't that big of a deal. So what we have to figure out now is kind of two things. So I guess one main thing is now our power routing. So we have to have 5 volt down here because all of these take 5 volts. The good thing with this is it's just kind of high current, but it's low frequency. The only thing taking 5 volts here are the bus switches, which then are your downstream devices. So there's not going to be any really high frequency component to it. So if we have to push the 5 volts over here, and as long as it's wide enough to supply enough current, that's fine. So we can avoid routing the 5 volts here because here we do have a much higher frequency component because there's obviously a lot of switching noise from the hub and all the data lines on here. And this takes in the 1.15 and the 3v3, but we only have one power pore. So we would either have to use something on our ground down here, which is not ideal because then we lose our interplanar capacitance between these two layers, or we have to route separate traces for each of these, which that is probably just going to depend on if there's any consistency with how these are set up, which it does not seem like it at all. So an option that I could see is if we were to take, yeah. So what I'm thinking we could do is, let's say we feed in our 1.15 or 3v3, just one of them, and a nice wide trace right here, or I guess on the right hand side, and have it dump in here, but fill only in this center area. Then we have our 3v3 come in on the other side, and we have it wrap around and go on the outer edge. So then if we need to get 3v3, we would take a trace here and drop it down to grab 3v3. Then if we need to grab 1v15, we would drop it, oops, we would drop it right here. And without going to an 8-layer board, I'm thinking that's going to be our best bet. unless if anyone else has any other thoughts, first look at it. That's what I am thinking. Unless we threw one of them on our signal layer, because as long as it's away from our differential pairs over here, it's not going to be doing anything on that layer. So that's something to keep in mind. Here, I guess for completion's sake, let's route our upstream port. Oh. Is it mad because it's not a capital for the router? Yeah, it's literally mad because it's not a capital. Outstanding. Which sucks because I like keeping these all the same. Wonder if we can't just do something like this. Alright, let's see if that fixes it. Yeah. So that's almost worth a bug request on the nightly, because that's obnoxious. It should not matter if it's capital or not. Oh, and on this, it would be on this side, I believe. This one may or may not work. Okay, let's see what that does. I'm just gonna run these roughly over there, because we're probably gonna have to adjust. Oh. Oh, that's the USB too. I was gonna say, why is it bypassing our mux? That would be because we don't need the mux. And we'll do the same thing and probably throw these on the upstream side closer to the connector. Again, not that. Do not believe it matters for blocking caps, but it would make sense for it to be closer on that side than the other way. Oh yeah, we press U. The link to GitHub in the description does not work. No? Okay. I'll make sure to update that. Here, give me a second. I'll post it now at least so you can have it. Actually, I think I can just pull it up on here, right? Yes. Make sure this one works. Yeah, so there it is. Oh, you found it? Good timing. Well, at least now I have the link to post the one that's working. That is super, super nasty, but we'll obviously get that. Oh, and they're even flip-flopped here. Okay, so we'll leave that for now. Ah, those are swapped too. Okay, we're gonna have to have a couple here change out. All right, so then, yeah, I'm thinking really the biggest thing to do. Oh, 1 second. Okay. Yeah, so I'm thinking not only just the next thing, but really the next, like the only real difficult part of this that I can see is what we do with the power distribution. Um I really think that doing it just this is kind of a nuisance with how they set this up. It would have been nice for them to have had some sort of consistency with where the two voltage rails are. And I get it probably didn't make sense in the silicone, and they need to have more to allow better decoupling. But that does kind of make it a pain on our end. Because we really don't have a lot of options without having, unless they intend this to be an 8-layer board, without using up that signal layer. So I guess, and what time is it? Got like do another like 10 minutes. I guess just to test, let's see what happens if we on our power pour. Let's do something like this. Fill type solid. And then what I always do is just solid for the start because it looks a lot better. Not because it actually really matters much. And I end up normally doing thermals, but it just makes the fill a lot nicer. So if we do something like this. And again, this is obviously just a rough little setup of how it would be. So if we have that as our power, and then we would have a big power trace or part of the pour heading up here. So now, with this being our 3v3, now we can tie in any of our 3v3s. Whoa. Haven't seen it do that before. Anyone got an idea how that's a feature? It double routes it? That's quite strange. Okay, so now our 3v3s here. I don't understand that. That's got to be a bug. I don't see why that would be an intended feature. What's weird is it only does it when I double click. So is that like a hotkey or something? I don't really know why that would be. Because if I click, it does it again. If I click and then hit exit, it doesn't. It's a diff pair double layer feature, but I'm not doing a differential pair. I mean, I can see how I guess it can be nice, but I'd like it to be a little more selectable than just double clicking, because that's normally how you would escape from a route anyway. Oh, it was a joke, yes. You didn't do the / sarcasm. How am I supposed to know? Okay, so now that. Okay, and I believe that's all. Yes. Okay, so there's all of our 3v3. So now, if we were to do... Oh, is there one? So now there's all of our 3v3, and as long as we make this presumably a pour, which goes to wherever a 3v3 LDO is, you know what we could do? So where does our 5-volt go? Is our 5-volt only for this and our LDO? So you know what might make a lot of sense here is, since the name of the game when you're doing power routing for a high-speed IC that's going to be doing a lot of switching, is you want to make sure its power connection is as low impedance as possible, hence why you do a pour like this. But if you were to have the rest of it strangled off by a smaller trace or something like that, that increases your impedance by quite a bit. So what might make sense is we have our power side up here. We run our 5-volt, like I said, over here. And that's a big pour. It fills up all of these. Then we have our LDO down here, which gives us our 3v3. That 3v3 dumps into here. So we have the advantage of having a higher voltage trace, which will have less current on it, and then dumping it into this side. Then for our 1v15, we do the same thing over here, but we have it with the 12 volt. So again, it's a lower current, so there's going to be less voltage drop because there's less current on it. I think that makes sense. Oh, and you agree. Fantastic. And then and what I was ultimately getting at is, so then on this pour, we would have 1.15 on our signal layer like this, and then have all of our 1.15s dropping down to it. That's the only part I'm a little unsure of. I don't see an issue right now, as long as we make sure we don't have to jump anything onto the signal layer for these. I think we're totally fine, because our power port is referencing our ground 2. Our signal, so this power, would be referenced and have interplanar capacitance to our ground 1 layer. So I think that works. Definitely, and I'll obviously push this after the video. Let me know if you have any thoughts with that, but I think that makes the most sense. And then it allows us to squish all this down because we have 2 regulators, one over here and one over here. But I'm sure there's probably a couple other ways to do it. But sweet. Yeah, so I think I'm gonna wrap it up for tonight. Make sure hit up the Discord if you haven't already. Link is in the description. I'll fix the GitHub link. and I will push this here in the next couple minutes, so it will be online. And I appreciate it, as always, guys, for tuning in and watching. Please let me know any other video ideas or suggestions, and I will see you all next time. Next week, there will be a recorded video, and then the week after will be the next part of this stream. So I will see you guys on a stream in 2 weeks.